we need to determine the formula of an acid salt through titration. What is an acid salt? An acid salt, it's a salt, so it's an ionic compound that's made from metal. In this case, it's going to be the potassium, and the anion, so the metal will form the cation. The anion is the conjugate base of an acid. What is a conjugate base of an acid? If the acid is hydrochloric acid, HCl, the conjugate base is the Cl minus. If the acid is sulfuric acid, it has two different conjugate bases. For the first dissociation of the acid, it's going to give one H plus and HSO4 minus, which is the hydrogen sulfate. Then the HSO4 minus will dissociate to give another H plus the SO4 2 minus, and this is the sulfate. If this is, for example, acetic acid, the conjugate base is the acetate. So you look up the acid, the conjugate base, it's the anion that forms after dissociation. What's the conjugate base of nitric acid? Nitrate, the NO3 minus, right? This would be the conjugate base of the nitric acid. Now here you have a potassium acid salt. So you know that it's potassium as the cation, but you don't know the anion. Now to know the anion, you need to know the molar mass. If you know the molar mass, you subtract the mass of the potassium. We will give you a table. One of the conjugate bases is what you are using in here. So you will be comparing the molar mass that you obtained through calculation with the molar mass in that table in your lab manual. You will be able to guess what is the conjugate base, and therefore determine the formula of the acid salt. To start, we need to prepare a solution of acid salt. Now, preparing a solution for you guys, this is not something new. You will need to weigh around 1.5 grams of the acid salt. Okay. So you need around 1.5 grams . When I say around, it means it's a mass very close to 1.5, but as long as you record the exact mass you obtain, okay, that's gonna be good enough. So my mass here that I have is 1.5063. Okay, so you write down this exact number, all the decimal places. So now you have your acid. Using this funnel, we'll add the solid to the funnel. Some of the solid will stay on the dish, so we can just simply wash it with water. Wash all the solid with water to make sure that all the weight of the acid salt is inside our solution. You wash the funnel, make sure no solid stuck to it, to the walls. And then you try to dissolve your acid salt. If you see that you will need more water to your solution, you will add more water. Okay? don't fill to the mark until that you see all your solid has dissolved. Okay? Now I will add to the mark. So I align my eyes with the mark, so I see one line, and I add slowly the water. If you want to use a water dropper, you can use it. Okay? That's adding water to the mark. Make sure I homogenize it. Make sure there's no solid left inside my solution. So this is my solution. The next step is to prepare my burette. When you put your burette, make sure that the graduation is facing you. Also that this is closed here. Okay. The burette, you will need to take 50 milliliter of potassium hydroxide. Make sure it's closed. You will add slowly. Make sure that you don't have air bubbles inside your burette. You will add a little bit more than 0. And then you will calibrate it to 0. Put your magnetic stirrer, magnetic bar. Make sure your burette is inside it. Make sure your stirrer works. Now with the other beaker, you take half of your solution. Then you will take the 10 milliliter volumetric pipette, attach it to the pump, and you will withdraw 10 milliliter of your solution. You will not force the solution to get out of your pipette, because some of the solution will stay inside the pipette, and this is accounted for. If you force it, it means you added more than 10. So what remains here in the pipette, this is accounted for. Just leave it in the pipette. Now, as we did for the acid-base titration, we will add 4 to 5 drops of an indicator, acid-base indicator, which is the phenolphthalein. The first titration we will do it, this is the rough titer. So I will be adding one by one until that the color of my solution changes. So I don't need to look down. I'll add 1 and look. Okay? Add 2 and look. So I'm adding 1 milliliter by 1 milliliter. I'm at 9 right now, and the color changed. So I will need a little bit less than 9. So then I take my pipette out. I will recover my magnetic bar. Then I will take another Erlenmeyer flask and repeat exactly the same thing. So the new Erlenmeyer, 10 milliliter. Should not forget to add the phenolphthalein, 2, 3, 4, 5, 6. Okay. So now it took 9 milliliter to neutralize the acid salt. I don't need to go one by one now. I will add 7 and then go dropwise. So from 9 to 16, I will add quickly, and I will stop the addition at 16, which means I added 7. Okay? So here I'll stop at 16. See, the color did not change yet. Okay? Now I will be adding dropwise. And I will hold the burette. Once I see the color persists, so it doesn't change, I will stop my addition. There you go. So I'm at 1 drop. So which means my error will be very small. Stop. You repeat this second time because you will need 2 values. You'll take 2 volumes. You get the average of the 2 volumes, and then you will use this average value in your calculation, as we will see in the post-lab discussion. Okay, so we have said to determine the formula of the acid salt, the only thing we can do is to determine the molar mass. Should record the concentration of potassium hydroxide, which is on the bottle, 0.1 molar. The volume of the acid salt solution, not the volume that you prepared, is the volume that you used for titration. It's 10 milliliter. Now the mass of potassium acid salt, that's going to be the mass you have weight. So it's going to be around 1.5. You put your exact mass. Now about the titration, for the rough titer, the initial volume you started at 0, and the final, say you stopped at 9. So the volume of KOH used is 9 milliliter, as an example, okay? Then you will continue, here 9, and here whatever values you will obtain, volume 1 and volume 2. Once you determine the volume 1 and volume 2, you need to determine the average value, which is equal to V1 plus V2 divided by 2. We don't consider the rough titer because it's not accurate enough. It's rough. Once you calculate the volume, average volume of the titration, you will use the equation between the acid salt and the base. As you can see, the acid salt ratio, it's 1 mole to 1 mole base, which means your titration, you will reach the stoichiometric point once the number of mole of KHA is equal to the number of mole of KOH. Now the number of mole of KOH is equal to the molarity multiplied by volume. Which volume? The volume average that you have calculated. This will give you the number of mole of acid salt. The number of mole of the acid salt is equal to the mass over molar mass. So the molar mass is equal to your mass that you have weight divided by the number of mole that you have found. But this is the molar mass of the acid salt, correct? Now you will have a table that contains the possible complex ions that you have used. The anion in the acid salt that you have used, it's going to be one of the possible 6 choices. That's why you need to calculate the formula mass of each. That's going to be A, B, C, D, E, and F. Now, the molar mass of the acid salt is equal to the atomic mass of potassium plus the molar mass of the anion. So the molar mass of the anion is equal to the molar mass of the acid salt that you have calculated on the previous page minus the atomic mass of, or the molar mass of potassium. That's going to be equal to X. Now you compare X to the values you have. Say you will find that D is the closest value to X. Therefore, the formula of the acid salt is so KHSO4. So this is how you can determine the formula of an acid salt using titration.